The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
We're going to continue working on our mini pinball kit. So today we're going to work on the upper half of the playfield and figure out how we can have walls and barriers and mechanisms that can be moved around in different configurations.
Like pinball Legos.
Yeah, like Legos, but
cool.
Not.
Then we're waiting for the PCB, so Felix is going to be working on some electronic things in the background as well. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, Felix, it's time to resume work on the mini pinball kit.
Awesome. We have this in-house board that we made.
Yeah, in a previous episode, we took this and we designed it over into Eagle. And we sent off to Osh Park, and we're waiting for those boards. And while we wait on it, I think what we should do is actually refine this and make it into basically a prototype of a game. When we've done all the separate pieces, let's bring it together into something we can play.
I want to refine this audio a little bit more.
What's wrong with it?
I haven't thoroughly tested it.
Weren't you going to test to see if we can just run the amplifier at full power and then change the volume based off the DAC?
Yes.
Did you get an answer on that yet?
No, I didn't.
Okay. Oh, I guess I should preface this. So a lot of these amplifiers, all they do is they amplify it by a certain amount of gain. And if you want to have a volume control, you have to either do it with a mechanical rotary potentiometer, a digital potentiometer, or adjust the volume of the signal you send into it. So my concern is if we send in a zero signal, well, it's not technically zero, but if we send in, a blank signal from the DAC into the audio amplifier, we might hear noise or hum or something.
Right.
So it was like decimal, right? It was like 0.0 up to 1. That was the volume range, right, on the code?
Yeah, I believe so. I got to look further into that because it's been a few weeks.
Okay. But could you work on that? And then we can basically see if, we can just do straight amplification, because the board that I designed and shipped off, it just does straight amplification.
Right.
There's no volume knob because it's cheaper just to do it with software. So this prototype has been around for months. I think it's time for it to be destroyed.
I've been looking forward to the next iteration of this.
Yeah, so we have that ball loading
Hey, where did that go? Let me pull that out from the oven.
We have all the separate pieces. We just have to bring them together. Yeah.
I knew I forgot something.
Out of the oven, huh?
Yep.
So this detects when the ball drains and also reloads it for a launch. So that will do both things. So we just have to take this, build it into this. There is one question though we need to ask, and that's, do we have enough room for a shooter lane here, right?
Oh yeah, because it's narrow, right?
Yeah, well these flippers are centered, but flippers often aren't centered. They're actually off a little bit to the left because you've got a shooter lane. Or maybe the shooter lane could just go over the flippers, it could like launch, just throw the ball up there. And then we have to make like some in lanes and stuff. And I mean, we just put these pieces of cardboard here as a test, but I should actually design this kind of more as a real machine. If you want to check into the volume code, I can start doing like the mechanical design of this.
Okay.
Here's the problem that I kind of foresee, Karen. The flippers are bigger and the ball is bigger, but the width of the unit hasn't really changed.
I could see how that could cause some problems.
Yeah, so this represents the loading mechanism that we covered in an earlier episode.
Oh yeah.
And it goes into the shooter lane here. So the shooter lane actually has to be to the right of the flippers. So flippers won't actually be centered on the actual machine. So the challenge we have is that we need to have like an out lane, so the ball can go that way, an in lane so it can feed the flipper.
And is the drain typically the size of the width of two balls, or?
Yes.
Okay.
That I don't know for sure. It seems like a good number.
Okay.
That's what we used before.
Okay.
So the flipper placement that you see here matches the prototypes thus far. Problem is, I don't think we're gonna have room for these fakey slings. See that? They would completely block the shot. But I don't know, maybe we don't need them. I mean, because they didn't really do anything anyway. They're just rubber bands.
Well, if we made the whole machine wider, what are the downsides of that?
Besides it being bigger?
You kind of arbitrarily chose the width and length, didn't you? I mean, you tried to keep it like sorta the same proportions as a typical pin, like a full-size pinball machine.
The original version of this product was basically a 1/2 scale pinball, and then we kind of took its physical size and then mapped this into it. So we're trying to keep this the same physical size, but as we talked about in earlier episodes, we scaled up the size of the flippers and the balls so this one would play better.
So if we made it wider, what problems could that bring? I mean, selling this as a product, we want to be able to kind of flat pack it so that you can sell it as a kit. So packaging wise, that could cause us issues because then anything that's on the main play fields would need to be that wide, and we'd need to be able to ship it, fit it in a box.
Here's an example. Like if we took the spacing of the flipper to the sling, I mean, look how much different this is.
Yeah.
Right. So really, well, yeah. If we take that as the baseline.
So yeah, how much bigger would we need to make?
Yeah.
How much wider would we need to make it?
Well, that's what I'm going to try to figure out here. So we basically need to have an outlane inside of here. Well, we could maybe shrink the sling a little bit.
Is that about 1/2 inch?
Yeah, so I think if we made the whole thing 1 inch wider, we could maybe almost do it. That's not too bad.
I don't see that being too unreasonable.
All right, Karen, I extended the width here, so about 1 inch, maybe closer to 1.25 inches.
Okay, it looks like the drain isn't going to be a problem with the hole shifted to the right. So
Yeah, it'll
that's
still
good.
find its way down there. Bloop, bloop, bloop.
So is that bumper above the flipper going to be in too far? That looks like it.
The sling?
Yeah.
Possibly. I mean, this is just one I grabbed off the original file. We could redesign it. I would say as long as there's...
That looks like it's blocking a pretty significant part of the flipper. I'd be afraid that you wouldn't be able to get that many angles with it that far over.
Yeah, possibly. But think about it, like how much throw are you really going to get that low anyway?
Well, but the ball has to completely clear when...
That, yeah.
So
what
I
if,
think it blocks more than you think. So
Yeah,
it either needs to be a little bit smaller or we need to make it even farther to the right.
Yeah.
Or like out.
Well, what if we took the center point as the basis and made whatever it is fit in here?
Yeah.
Well, yeah, we could just have 2 posts and then you wrap a rubber around it. That'd be simple.
Okay.
But if we had them like approximately here, that means they'd be above the center point of the flipper, which means it's pretty much impossible for that rubber band to affect an actual shot. But you could get some bouncy action, like bing, 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 and you can still get a ball behind it.
Okay.
So we'd have an in lane and out lane. Yeah, I mean, all the features would be there. It would just be as compact as possible. This curve I don't really like, but it would still function because it's going to do this. It's going to go.
Well, could we make that a little more curved and just raise those posts up a little bit?
I guess we could. Well, the thing is, like, is this a piece of wood? Is this?
Well,
a
yeah,
3D
I guess we
printed
still have
part?
to figure out how we're going to
I mean,
that.
we could. It wouldn't be a big deal to put a curve into it. I mean, that would give it a much nicer feel.
Well, and we were talking about taking PET-G and curving it, so maybe we need to
We could do that.
put up
Although
a prototype of that, test it out, and see what kind of curve we can get where it won't make the PET-G too brittle if it's too harsh of a curve.
We could put a curve in it and also have like slits in the PET-G to help it bend.
Yeah,
like when people
the
laser cut
hinges.
wood. Yeah, that could work.
Yeah, the laser
Because
cut
then
hinges would work.
I mean, this doesn't need to be this thick. It just needs to have a top portion.
Right.
So we could just have like, if this is the PET-G, which is 115, so you can go 90 degrees, 15 degrees, 15 degrees in the other direction. There we go. How many times am I going to type 15 wrong? Crying out loud. There we go. So it would be like that right there. But it would be curved, of course.
So yeah, we would have to figure out what curve would need to go from the vertical piece to the 15-degree piece.
Yeah. Okay, what do you want me to do, Karen?
Okay, so if you figure out the linear distance of the center line of that curve, that tells us how long the piece needs to be where the hinge is.
Yes.
But then we also need to do the math of the outer linear distance of that curved piece versus the inner linear distance of that piece.
All right.
That will tell us how much material we need to remove in the holes of the
So we need to
hinge.
figure out the difference between the circumferences, or the linear distance.
The linear distance
based
of the
off their circumference.
the outer of the bend and the inner of the bend.
Okay, so let's take 1.4 inch diameter, multiply it by pi. Boom, we get that number. We copy that just in case. We divide it by 360 degrees. We get that number. So this is 90 degrees, but we subtracted 15, so we multiply this.
75.
Yeah, so this is linear distance per degree. We multiply it by degrees, and we get, boom, that number, which is really long. Let's put that into the computer. Wow, not even Stephen Hawking could remember a number like that. The other one's 1.6037, so same thing at 1.6307. I actually don't like math, but it's a necessary evil. All right, so, wow, that's quite a difference.
No,
did I do that wrong?
You did that wrong. So did you need to do 360 divided by...
No, I'm doing the outer radius. So
Yeah.
times pi. That's a big difference.
There's no way that's 5 inches.
The other one was like 4, right? Yeah, well, divide
it?
by 360, multiply
you're
by
right.
75.
Yeah, no, that's right.
So that is, I like also how they say lorem ipsum now.
Yeah,
So you
it's
actually know there's text there.
Yeah, I like it.
Yeah, there's our difference.
Okay, so it's not a lot, but so we just need to make sure that the holes in our hinge remove at least that much material to allow the difference between, in theory.
Yeah, which is roughly 1/10 of an inch. So
And
now
then we can even think about if we're cutting the material, do we want the outer bend to be the top of the material or the bottom when it's in the laser? Because when you're cutting the
Because of the
plastic with
kerf?
the laser, the kerf, and then it's slightly angled.
maybe you should explain kerf to the audience.
So kerf is the amount of material that is removed by your cutting element. So with the laser, it's the amount of material that's removed by the laser when it's cut. With a saw, it's the amount of material removed by the saw blade. So however wide your blade is, that's how much extra material is going to be removed. So if you're cutting down a 4-foot piece of wood to a 3-foot and a 1-foot piece, you won't actually get a 3-foot piece and a 1-foot piece. You're going to lose the thickness of your blade. So
Yeah.
with the laser, we lose the thickness of the laser. But the other thing with the laser is it actually is focused, so it comes down like this.
And it melts.
And it melts, and it's melting.
Cuts like a V.
Yeah, it's melting the top of the material more than the bottom, so we will end up with a slight angle, and it might not be super noticeable to the naked
Yeah.
eye, but it will make a difference when we're doing
So if
precision
anything, you'd
cuts.
probably want that to be on the inside, the slight angle, because if it's folding in, I think that makes sense. Yeah. All right, so we're going to use the 0.99 as our length, and then we're going to use the we're going to use
difference.
yes, we're going to use 0.99 as the length, and then use the difference between the inner and outer circumferences as our slit compensation.
Yeah. Well, looks like it pretty much is making it.
That's not bad. Yeah, maybe a little closer on the spacing.
I don't know.
That actually works pretty good.
And I like that we don't have to worry about any material being removed from it. It's good to go as soon as it's cut.
Yeah, something to think about. Is it going to hold the right shape? Because there's not going to be slits under this, only under the long portions, right?
Right.
So is it going to hold the right shape with those slits? I guess that's the next thing we can test, right?
What if the Playfield was... Oh.
What?
What if the Playfield was 2 layers and the...
Turns out dropping tools directly on it breaks it.
Yeah.
Oh, weird.
So what if the Playfield was 2 layers? The bottom layer has all of the holes for all of the tabs in whatever configurations you could want. And then the top layer only has holes for like that configuration.
I'm confused.
Okay, so we've been talking about customization. So if you want
Yes.
like different habit trails or different bumpers in different places,
What if you drew this on the whiteboard?
sure.
Okay, what are you proposing?
Okay, so rather than having one piece as the Playfield,
Yeah.
because we want to be able to make this somewhat customizable, or at least potentially have different like skins or themes
Yeah.
possible. So what if we came up with multiple configurations? So it's still limited, but you have more than one option. So what we could do is have an underlayer that has all of the holes for tabs in like a few different configurations. So they'd be here and here.
You mean the tabs
and
for
here.
the kind of things we're designing right now?
Yeah, and it would be
So it's
everywhere.
like a grid, yeah.
Or however. And then you would have, so like say you want to do the like spaceship skin. It only uses like these 4 holes. So you would have a second thinner layer that would go over the top that would have
Oh, they would have only the
slits
holes
here.
that fit the theme.
And it could also potentially have guides that are only cut out of there. So like we were
that
saying,
show
we can
you
figure
how to
out,
line it up.
yeah, so like for the plastic pieces, if we need it to guide that bend and we only want to have tabs here and here,
Yeah.
you could have that in the thinner piece, and this could also have the artwork on it. One of the things that we've had some fans
Yeah.
talk about is like, okay, so if you want to be able to make it customizable, we were talking about doing punch outs where like you pop
Yep.
out, but then you still
I-
have holes and stuff, and so
I like
this is
this
the way to do
idea.
that.
I think the question is, what is this material?
Yeah.
And is it something you could get at like FedEx, Kinko's? Do we include like 3 sheets you know, like 3 generic theme sheets, and then also the templates if you want to make your own.
I wonder if you could do.
So this would probably just be riddled with holes
Yeah.
for both tabs, pop bumper slings, also insert lights.
Yeah, and for now we can use the chipboard that I got from the Game Crafter as that top layer.
Well, also, yeah, there's the ball loading mechanism, so we have to think about how adding a 16th or whatever this would be would affect the things that are in the game already. I mean, it's probably not going to be a big deal, but we still have to take it into account. The tabs and the hinges worked, so I'm going to incorporate those into the existing design. I'm not going to do all of the holes quite yet that Karen talked about because I want to make sure that the basic stuff works. So I'm going to turn all of these slots and tabs into our new super tab, and that is exactly what I called it. See, it's the super tab. It's like if you spend too much money at the bar, you get hit with a super tab. Yeah, so the lower level stuff I'll do first, and I think what I'm going to do is basically build this up so we can actually, make a shooting prototype using these tabs, and then we'll figure out the best place to put all the holes up here in the main playfield section. But I do like Karen's idea of just littering it with these tab holes, and then they're only exposed if the art shows it, which means you have one playfield and just multiple thin pieces of art that can go on top of it.
That was the long side.
All right, Karen, so here is the first prototype.
Okay.
I put X's and pluses.
Oh.
My X's and my pluses, they want me like a ghost, they haunt me. Okay, so this is the shooter lane.
Okay.
Ta-da! Look at that. So we have 1 inch spacing up here, but these are kind of like constants. These are 2 inch spacing. And then this one goes here. This hasn't changed. Ta-da, right?
Oh, okay.
So I guess we need to figure out some living hinges here. We have some 4 inch diameter curves and 2 inch diameter curves, all with living hinge girls. Living hinge girl.
I like that you made the hinges on these so long so I can do crazy things like this.
Whoa,
Yeah.
that wasn't
Ball
even
be like,
planned. And we can use the diagonals too. Look at that. Wow. I don't know how you'd get the ball into there, but it's fun for the whole family.
So if I were to be like, or like,
Yeah.
I have the.
Did you have to make
flick it
the
up.
sound effect though?
Yeah, it doesn't go in unless you make the sound effect.
So that'd be a good ball launch curve. Oh yeah!
Man,
Like we could do this.
getting exciting.
It's getting exciting in here. Try that.
All right, a little more oomph.
Wow!
This is starting to get pretty cool.
Cause it's beautiful, baby.
Hey, I finally finished wiring up this digital potentiometer. All right, so I've removed the dual potentiometer and I've wired up the two X9511 push-button potentiometers. And here's a schematic for that. So I put headers here on the board for it, and I have this little breakout. And so plug that in here. Now the way the circuit is working, we have the DAC 0 and DAC 1 coming into the V high of the X9511, and then we have V low going to ground, and then we take the wiper and send that to the amplifier left and amplifier right. It's amplifier left plus and amplifier right plus. Correct that on the schematic there. So we got that hooked up. And right now on the Teensy, it's just running a loop playing some sound effects. So we'll turn it on and we can see how this works. All right, here's the sound. Let's go to maximum volume. Now let's turn it down. All right, that works. At lowest volume, there's no buzzing or hissing or anything. This works just like the knob potentiometer, except it's with buttons.
Well, we came up with a good idea of how to make movable walls on the pinball machine.
Yeah, I think this will work.
Yeah, so I think we need to get some lights and switches in this, but it seems like we're coming along pretty well.
Yeah.
Well, that's all the time we have for today.
Do you have any ideas for our mini pinball kit? Tell us about it on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Let it go. Hey Karen, did your grandma ever tell you to listen to your heart? She lied. I'm squanching here. Go to your room. I don't wanna. Well, you know, I think copyright should be valid for 1 trillion years after the death of the author. We don't agree with you, Mickey. Oh, well, you agree with all these billions of dollars I'm gonna give you? Oh yeah, I think Mickey's got a point.
60 iterations off the central finite curve.
It's the oldest video game record that is still standing, and a modern speedrunner named OmniGamer has done a lot of calculations, and he doesn't think that original time of 5.51 seconds is possible. The guy who runs Twin Galaxies asked me if I could do some analysis using a real Atari, so it's a good excuse for me to build a RAM analyzer. I'm so glad the cursor menu is covering up the thing that I want to measure.